Okay, so today and tomorrow we are going to talk about two laws. The sine law and the cosine law that are going to help us solve triangles that do not have a right angle. So yesterday we did questions like this, where if you have the big triangle ABC, then you can use a line that is 90 degrees to the base of the triangle, which when you were in grade 9 and you did shapes and geometry, you would have called that the height of the triangle. And so yesterday we did many questions where there was a triangle that was not a right angle triangle, and we had to use wherever we could find a right angle triangle in order to solve for the side or the angle that we needed. So what happens when we can't do that, or we would like to find a different way to solve for whatever side we need? The sine law and the cosine law are both for non-right angle triangles, and the difference will be the things that you are given, then that's going to help you decide which of them to use. So are we looking for a side given its angle, or do we have to solve for an angle given all the sides, something like that, which is what we'll do tomorrow. Okay, so when numbers are written on top of one another, we call that a ratio, right? So if we drop a height and cut this triangle and make a right angle, then we can use SOHCAHTOA if there's a right angle. So if you do sine of angle B, that would be the H side over side C, or the hypotenuse. And then to get C out of the bottom, we rearrange. And if you do sine of C, the angle over here, then the opposite side is also the height. So if you have two of the same things equal to each other, you can set them equal to each other. We call that substitution. So if C times sine B is equal to H, and B times sine C is equal to H, then that means that these two equations have to be equal to each other. So if we want to rearrange them and not have to use the height because it's not cutting it right in half, so we don't really know what this side is or this side, it's actually not helping us. So we are going to use this, where we put what usually or often when you write a ratio, it has to match. So in the top, when you have capital letters, what do capital letters mean? Angles or sides? So angles in the top, sides in the bottom. We are also going to do one where you do sides in the top and angles in the bottom. Okay, so when you write a ratio, you can still follow the math rules that maybe you learned way back in grade 5 or something when you first started writing ratios or fractions. One of the big things with the sine law and cosine law, just like SOHCAHTOA, we always had to label first. So when you label, then that can be tricky. So if you look at somebody's work, or if you look at the solutions to something, or if you're an external video watcher, then sometimes people will do things like this. Angle B, the side opposite to angle B is side B. Angle A, which I've put at the top here, and side A are opposite to each other. Angle C and side C are opposite to each other. So often people will do this. So not unlike SOHCAHTOA, even if I write down the formulas for SOHCAHTOA, you have to decide what's the opposite side, what's the hypotenuse, and what the adjacent is. And the same thing with sine law and cosine law. So what you need to do is figure out which side goes with which angle, and that can sometimes be tricky. So label the angles with capital letters. Generally speaking, when you do non-right triangles, we are not going to do theta. We'll use capital letters. Do that first, then the lowercase letter is opposite. So you label the vertices first, ABC or whatever, and then the side opposite will be that side that corresponds to it. Capital C, lowercase c. Capital B, lowercase b. Capital A, lowercase a. Because unfortunately it is going to influence the math, and there is no way for you to tell that it's right or wrong. That's its own formula.
So it's equal to that as well.
Yes, but that's given to you.
Since both equations are equal to h, we can say that c times sine b equals b times sine c.
Substitution. If these are both the same, then these have to both be the same. You're like subbing this in for h, or subbing this in for h, either way.
What does that have to do with the fraction?
Then if you want to have the angles on the top and the sides on the bottom, then you rearrange. Divide by c, the c's cancel, divide by b, the b's cancel, and you would have sine b over b, sine c over c.
We don't have to rearrange it, right?
No. Okay, so when you do these questions, so we're going to do stuff like this, okay? So you have to decide, do I want to evaluate or leave it as the letters, okay? And it's not a big deal. You still want to make sure you have degrees. Whoa, that is not a G. Okay, so get to know the calculator that you are going to use. Sine 49 is 0.7547. It only says 4. Okay? And so that is not all it is. It is not a nice number. So then again, some people are okay with rounding. Some people, that's frustrating because then it can change your other answer. You have to decide. But sine of an angle, so this is an angle. This would be an angle. It's just a ratio. It is just a number.
Yeah, there's not No, I tried
that's
this time.
0. Negative 0. Why does it say negative? 0.95953.
This calculator's in radians.
Yeah, that's what I was trying to tell you.
Did you do the quiz in radians?
I did. My guy.
Oh my god. That's a 0 right there.
I'll take a look. All right, so there is two versions of the sine law. Okay, so one where you can, if you're looking for a side, you put the side in the top, and one where you're looking for the angle, you put the angle in the top. But you know, we have been cross multiplying, so you know how to solve something like this. So you can use one version of the sine law over the other, it doesn't matter, okay? So when you have something like this and the unknown is in the top of the fraction, then maybe you want to use inverses. So I'm going to do this one. I'm going to evaluate what I can. 4 divided by 7. Which is not a nice number, but that's okay. Then how do I get rid of the 3?
Times 3.
All good. It doesn't really say how many spaces. I'll do 1.
Yeah,
For when we do the second example, are we allowed to do either, what was this one, inverse? Are we allowed to do either inverse or cross multiply?
No, I would recommend. When the unknown value is in the bottom, then I recommend, when you're in grade 10 at least, to do cross multiplying. And again, you can decide sine 40 yeah. So sine 40 is not a nice number. Sine 50, not a nice number. So I am going to leave them as they are. I want the unknown to be on the left. That doesn't matter, but most students would prefer that. So a times sine 50. And then sine 40 times 13. Now, here's the issue. It is not sine 40 times 13. It's 13 and the sine 40 multiplied, okay? So I'm going to write it like that to not mess me up.
how would you mess up?
If you didn't use brackets, or if you did sine 40 times 13, that would not be correct. Okay, and now maybe you're like, okay, Ms. Todd, that's enough. I'm going to round now, and that's fine. Even though there are ugly numbers all across the board, now what do I do? How do I get a by itself?
Divide by, well, sine 50.
Yes.
Would you have just left it as sine 50?
Yep, for sure.
It's 10.9.
Yep. So this is a typical use of the sine law. When you use the sine law, so once we learn cosine law tomorrow, and the triangle is not right, which means it doesn't have a right angle in it, it's not going to say use the sine law to solve, use the cosine law to solve. You have to figure that out, okay? So when you do the sine law, we sometimes, again, if you're an external video watcher, they talk about a complete ratio. So once you have an unknown in the 4 terms we have, you can't have any more unknowns. So you have to know a side and its angle. So that's why the labeling part is important, okay? So again, you can, actually I won't highlight this time. You can circle them. Angle A is up here, side A is across from it. Angle C, side C, angle B, side B. That was a terrible. Monday. So the difficulty, once you get the formula again, sometimes people will say, as soon as I say I'm going to give you the formulas, you stop practicing, okay? So there are a couple of things about the sine law. First of all, there are 6 terms here. Really, when we solve cross multiplying, you only want 4. So the sine law, all 3 sides, because a triangle has 3 sides, is technically this. All 3 angles is technically this. You can use the sine law with any version of what you're looking for. You need 1 complete ratio and then 1 unknown at a time. When we did similar triangles, so again, if you were like, oh, why did we do this? It's so annoying. Because we did write the ratios of the 3 sides. However, all you needed to use was 1 complete ratio. So I really, really encourage you to practice manipulating the formula, because you're going to get the formula. That does not mean you're going to be good at it, okay? I also encourage you to look at the homework, because one of the difficulties is labeling the triangle. And if you can't label the triangle and you stop, then you would lose all of the marks for the question, okay? Which is not what we want. So this question, all we're going to do is label. We want P, Q, and R to be the angles or the vertices, and then lowercase p, lowercase q, and lowercase r for the sides. So it doesn't matter. If I put P up here, side P is across. If I put Q here, side Q is over here, across. And then last but not least, R. So you could have gone P, Q, R, and then this would be Q, and this would be R. Doesn't matter. No, we're not going to do anything else here. It's up to you. So in a question like this, it tells us the vertices. It tells us side C. That's very lucky. And this is the complete ratio. It wants us to find A and B. So sine 45 and sine 65 are not the same number. So if you labeled side A in the wrong spot and side B in the wrong spot, then you would lose marks. Would you lose all the marks? No, but you would lose some of them. So A is 45. Side A, does it go here or here? Right side.
So what do you mean by complete ratios?
We have an angle and a side. Okay, so when you do the sine law, it's up to you, really. If you like one version over the other, it just requires some cross multiplying sometimes, but we can do the side version. That's what we're, ooh, that's a terrible A, sorry. Okay? Substituting the values we are given will show us which one is a complete ratio. If you're not sure, don't worry about it.
How can they all be sine?
Because it's the opposite side.
What's the last number?
Oh,
Oh, they're both off. So we're not, there's no problems here.
No. That's why yeah. Okay? Still want to make sure you have degrees, no radians. Can you solve for two unknowns at the same time? No. So does it matter if we solve for A first or B first? Also no. I'll just do A first because that's first. So remember, you can manipulate the sine law. We can write two different 4-term ratios. So to solve for A,
Why is there two A?
we have to do A and B. So I'm going to do, that's a 9, sorry. Okay, you should have a calculator there with you. Don't wait for me. So you have some options. When you write it like this and the unknown is in the top, 9 divided by sine 70 is a number. Is it a nice number? No, it isn't. However, if you want to evaluate that, you can. You can also cross multiply. Yes? Okay? So I'll do this one inverse operations, and I'll do this one cross multiply. But if you have a calculator there, don't wait for me. Do it yourself. See if we get the same answer. And I lied. I didn't show mine.
What if it's a number like 0.363996?
I usually do 5 decimal places, but it doesn't matter. Does it say how many places? 2 1 decimal place. No units, perfect. Okay, and then this one, I'm going to cross multiply, and I am not going to evaluate what they are. I'm going to keep the words. Uh-oh. I did round. You do not need to cross multiply. You do not need to do inverse operations. You do not need to show both. You pick what you like. That's supposed to be 0.7. The next question you should be able to do too. So label the triangle. Don't wait for me. Label the triangle. Figure out what you're trying to do. Okay, so we need to label the angles are good, sorry. What is 16? Side B or side C? B? And what is 23? A? Took the words out of my mouth. Okay, so are we going to use C at all? Do we know anything about angle C or side C? No, so that's not helpful. Okay, so then you can even do only what you need. Since this time we're going to solve for the angles, I'm going to put the angles on the top of the ratio. But again, we have solved for variables in the bottom, and you know what to do. So you can use the same version every time. 8.7.
I think you just use the sign directly.
Oh, I just simplified what I was saying.
Did you get close to this?
Yeah, I got 8.1.
Oh, that's fine. Okay, so when you're going to use the sine law, give it a check. Do we have a complete ratio? Yes, we do. When the one advantage, usually students like sine law better, that if you flip it around and put the unknown in the top, then using inverse operations is not so bad, okay? Then, once we solve for A, do I have to do sine law again for C, or can I use a shortcut?
Shortcut.
What shortcut?
I just
Okay, let's just do A first.
Oh, to do for C, A squared plus B squared equals C squared.
Can't do that. It's not a right angle. Hold on, let's do this first.
You didn't give the answer either.
It's all good.
I kind of did.
Bravery is appreciated. Especially when you're multiplying by 23, you know, then maybe when you do angles, you'd rather do inverse operations. It's up to you. Yes?
Why do we flip it? As if we didn't flip it, then we still get the same answer.
Absolutely. To be honest, we flip it because this is the first time you're doing it, but you know how to deal with unknowns in the bottom, right? Okay, this one again, ugly. I'm not going to clear my calculator. I'm just going to multiply by 23. You can cross multiply, yep. I did sine 36. I pushed equals. Then I divided by 16, and I got 0.0367. This is just a number. So I simplified all I could, but that is, you do not have to do that. Okay, so when you get down here, again, you should have a number less than 1. How do I get rid of the sign? Yes. Sine inverse, good, yes. $57.7 degrees. Sometimes, does it say? Maybe you would round it to 58, that's fine. Actually, I'm going to do that. I'm going to put 58. Okay, then now watch this. If I put the 58 in angle A, how can I do a shortcut to get C? Yes. Save yourself some time. But you could do, actually no, you don't have that. This is what we have to do. You don't have side C. Okay, so the trap of giving formulas is then you don't practice, okay? So practice these questions so that you feel as good as you possibly can.